Hello friends, I am Dr. Prashant Sharma and you are watching MEDICO'S Hub. This is my second lecture on citric acid cycle and I am going to discuss the reactions of citric acid cycle. In this video, we'll learn and remember the reactions of citric acid cycle. So, when one molecule of acetyl coenzyme which is having 2 carbon enters this reaction, then a series of 10 compounds are formed. I have written 5 compounds here and 5 here. We'll number the compounds, compound number 1, 2, 3, 4, 5, then 6, 7, 8, 9, 10. Now, it's very important that the first compound which is formed is citric acid, or we can write the citrates. So this compound which is citrate is formed when acetyl coenzyme A reacts with oxaloacetate. When it combines with the oxaloacetate, then citrate is formed. This acetyl coenzyme is of 2 carbon, citrate is of 6 carbon, and this oxaloacetate is of 4 carbon. So 4 carbon plus 2 carbon and citrate is formed, which is a 6 carbon compound. The enzyme which mediates the synthesis of citrate is citrate synthase. One molecule of H2 is released and also the reduced coenzyme. Now, this is the compound number 5. Compound number 5, which is alpha ketoglutarate, is the only compound which is having 5 carbon. So compound number 5 is the only compound which is having 5 carbon. It means that the compound before, which are formed earlier, are having 6 carbons, and which are formed later are having 4 carbons. 6 carbon to 5 carbon means decarboxylation, and in the same way 5 carbon to 4 carbon again means decarboxylation. So decarboxylation will occur between 4 to 5 and 5 to 6. Now, when this citrate is formed, citrate is having 3 carboxyl groups. That's why it is also known as tricarboxylic acid cycle. Now, next compound will be cis-aconitate and isocitrate. Both of these steps are mediated by same enzyme, that is aconitase. Aconitase. One molecule of water in, one molecule of water out. Then again, these two steps are mediated by the same enzyme, that is isocitrate dehydrogenase. And it's important to note that compound number 4, 6 and 7, these 3 compounds are basically having succinate. One is succinyl coenzyme A, second is succinic acid or succinate, and one is oxalosuccinate. So the compound which is not starting with succinate name is here, that is oxalosuccinate, while succinic acid or succinate or succinyl coenzyme, these are here. So we'll write first the oxalosuccinate. And last 4 compounds are not having coenzyme A. So this should be the compound with coenzyme A, that is succinyl coenzyme A, and this one is succinate. So isocitrate results in formation of oxalosuccinate, and oxalosuccinate results in formation of alpha ketoglutarate. Then alpha ketoglutarate is converted to succinyl coenzyme A in presence of enzyme. This reaction is catalyzed by enzyme alpha glutarate dehydrogenase. It means that dehydrogenation should have occurred. Here also dehydrogenation has occurred. In this step, NAD plus is reduced to NADH. In the same way, NAD plus is reduced to NADH. Now, this step is mediated by succinic thiokinase. Then, next step, succinate is converted to fumarate, and then fumarate will be converted to malate. In this step also, one FAD is reduced to FADH2. So the enzyme will be succinate dehydrogenase. In this step, one molecule of GDP takes one anorganic phosphate and becomes GTP. Then this is mediated by fumarase. This step releases one H2 molecule, and when malate is converted to oxaloacetate, one NAD plus is again reduced to NADH. So the enzyme will be malate dehydrogenase. So this is the Krebs cycle. It's important to note few points that dehydrogenation has occurred after third compound, fifth compound, seventh compound and ninth compound. After third, after fifth, after seventh, after ninth, and only after seventh FADH2 is formed, while after third, fifth or ninth NADH2 has formed, that is NADH is formed. So it's important that dehydrogenation has occurred in 4 steps. One step is consuming water while 3 steps are releasing water. So 2 molecules of water will be the net output and 1 molecule of GTP is formed. Decarboxylation is occurring at 2 places. Final inhibition if discussed, then fluoroacetate, it inhibits the citrate cis-aconitate reaction. Arsenite inhibits the alpha ketoglutarate dehydrogenase catalyzed reaction, and malonate inhibits the succinic dehydrogenase mediated reaction. So final outcome of this citric acid cycle is 3 NADH, 1 FADH2, 1 GTP and 2 molecules of H2. So these are the reactions of citric acid cycle. Hit the like button, share and subscribe our channel to get the latest updates and notifications.